Hi, folks. If you haven't done Friday's Desmos activity, the classroom activity, our discussion right now might not make a whole lot of sense because I'm going to refer to that activity quite a bit. For example, there was a video of a guy shooting a basketball into a basket, and he was like standing right here, right? So his sorry for the poor artwork, but he's standing right here and he's shooting the basket. So the y-intercept represented his height, or it is the height. It doesn't represent it. The y-intercept is his height. The vertex was the highest the ball ever got in the path to hitting the basket, right? So this is called the vertex right up here. And then there was that line of symmetry or axis of symmetry. So this vertical line kind of breaks the parabola into two equal parts. There's a left-hand side over here and a right-hand side to the parabola, and they're identical to each other. So that makes this a line of symmetry. Okay, so these were the notes that we took on Friday. Let's see, what else do we got? We got x-intercepts. Here's an x-intercept. That would be where the basketball hits the ground if it doesn't hit the hoop, right? The hoop was over here somewhere, the basketball hoop. And so if he totally misses the basketball hoop and it hits the ground, then it's called an air ball, right? But that's the x-intercept. That's our x-intercept. And then we had another x-intercept over here, which didn't really make sense in the real world because the ball was never back here. But this parabola would go on, like the mathematical model would go on to the left forever, and then it would go on to the right forever. But we said there's some unrealistic parts to our graph, like the basketball is going to hit the ground. It's not going to go down through the earth forever. And it was never over here, right? But it still, in math terms, has end behavior. This is called the end behavior. As we go further and further out on the x-axis, the y is going down or it's decreasing. As we go out further and further on the positive x-axis, the y is going down. It's decreasing forever, right? So the end behavior is these two arrows telling us that the y values are going to go down in this situation forever. So this is a downward opening parabola. That's what we call that. We can have parabolas that go up. So our parabola that goes up, let's make a little graph of that. It might look like something like this, okay? So it still has a vertex down here. That's our vertex. Still has an axis of symmetry, but you can see the end behavior is up on this side and up on this side. That's the way parabolas are going to work. They're either both going to be up for end behavior or they're both going to be down for end behavior. All right. So how do we use that information to graph equations that are quadratics? Because this, up in Desmos when we were doing it, which we couldn't see the back end of it. How did the programmer make this parabola show up on the screen? Well, they had an equation that looked like this: y equals ax squared plus bx plus c. Please add that to your notes up here on day one. We should have probably said that on Friday, but I didn't want to kind of clutter our thinking. We were trying to identify these vocabulary words, but the a value is the coefficient that's in front of the x squared. So let's come down here to our problem today. Our a is going to equal -3. Okay, so that's our a value right there. The b is the number that's in front of the x. So this is our b value right there. And the c is the constant that's at the end. So this is our constant over here. Now, as I circled that negative in front of the 4, I should have circled the positive that's in front of the 6 because that's important. It's important that we pay attention to the sign on the b value. And it's important that we pay attention to the sign on the a value. So this is going to be our b value right here, right? The coefficient of the x. And then this is our c value. These are three important numbers to our graph. So in video 2, I'm going to show you how do you use those three numbers, the a, b, and the c, to actually put a graph down on our paper, because we're going to do our homework today on our paper. And there's going to be roughly 5 steps to doing that. Okay, so set up today's notes and then come on back and I'll fill you in on the rest of the discussion. All right, thanks for watching my video.